Welcome back to Mr. channel. Today we are going to walk you through the entire process of building your own high-performance lithium iron phosphate battery pack from scratch. Putting together your own battery solution isn't just cost-effective, it gives you complete flexibility to customize exactly what you need. Let's get started with everything you will require for this project. For our demonstration, we will be assembling a 12.8-volt 100-amp-hour battery pack using 4 3.2-volt lithium iron phosphate cells. Now, in terms of additional components, you will need to have a proper battery management system with all its wiring accessories, some sturdy bus bars for connections, the right screws and nuts, insulating epoxy plates, and high-quality fiber tape. When it constitutes, make sure you have a reliable voltmeter for testing, an internal resistance tracker, the correct size hex wrench, and the appropriate screwdriver on hand before beginning. The first critical step is testing and matching your cells properly. You will want to measure the internal resistance of each individual cell. We recommend keeping the variance between cells under 5% for optimal performance. Cells with higher resistance tend to heat up more during operation, which leads to faster degradation and can significantly shorten your battery pack's overall lifespan. If you have multiple cells available, take time to select the one with the most closely matched resistance values. Now for the actual assembly process, identify the positive and negative terminals of each cell. Then flip the orientation of two selected cells to facilitate serial connection by aligning positive terminals to negative terminals between adjacent cells. Place epoxy plates between each cell. These serve multiple important functions. They prevent any accidental short circuit, help maintain proper spacing, and provide structural stability. Once everything is aligned correctly, wrap the entire battery stack securely with high-tension fiber tape to keep all components firmly in place. The next step is making all your electrical connections. Use the proper bus bar to link the cell terminals together. Then tighten everything down securely with the correct nuts. This is where your hex wrench comes into play. Before moving forward, it's absolutely crucial to double-check all your connection with a voltmeter to verify proper wiring. Now we come to install the battery management system, which is essentially the brain of your entire battery pack. Here's how to wire it correctly. First, potentially connect all your sense wires, but hold off on plugging them into BMS just yet. Follow your manual's wiring sequence carefully. Here's how the sense wires connect. The red wire runs to each positive junction point in order, and the black goes to main negative terminal. In addition to connecting the sensing wires, the main positive and main negative terminals must also be connected to the battery pack's out power cables. The power cable from the battery's main negative terminal should be routed to the B port of the BMS protection board, with the negative output cable then connected from the BMS's P terminal. During this entire wiring process, all wiring terminals must be properly oriented according to the BMS board's installation position while maintaining consistent alignment between wire routing and terminal direction. You will also need to install the temperature probe into the NTC port and connect the Bluetooth module to the UART port if your system includes these features. Then secure the temperature probe onto the battery cells. It can be mounted either on both sides of the battery pack or between adjacent cells. Here's a critical safety check. Before finally plugging the sense wire into BMS, test each red wire's voltage relative to the black reference wire. You should see the voltage readings increase in increments of about 3.2 volts as you move from one cell to the next. Only when you have confirmed this proper voltage progression should you make the final connection to the BMS. Next, Download the Smart BMS app from the application store and open it. Select the local monitor option for Bluetooth connection. Then add a device corresponding to serial number on the Bluetooth module. Tap the connected Bluetooth device to access the information page of the corresponding protection board. At this point, the battery capacity will still display the factory default value. You will need to charge the battery to allow the BMS to automatically calibrate the state of charge. There are 3 conditions under which the BMS will automatically calibrate the SoC to 100%. Any one of these conditions be met will trigger the calibration. Once the SoC has been calibrated to 100%, you can update the rated capacity to match the actual rated capacity of the assembled battery pack. You can now easily monitor battery pack data and data directly from your smartphone. The app also allows configuration of BMS protection parameters. Make sure to strictly follow the battery cell manufacturer's specification when setting these parameters. To wrap up our demonstration, we connect our freshly assembled battery to a PO M60 Ultra solar charge controller and successfully powered a cooling fan. Everything operates smoothly and maintains stable performance. And there you have it. You've successfully built a safe, smart, and durable battery solution. If you have any questions about the process or want to share your own tips, we'd love to hear from you in the comment section below. Thanks for watching, and we will see you in the next tutorial. Happy building!